We all learn about the scientific method in school, right? It feels so solid, so dependable. It's pretty much our ultimate tool for figuring out what's true. And for good reason. This is the process that literally took us from just staring up at the stars to actually walking on the moon. For centuries, it has been our most reliable engine for discovery, our gold standard for separating what's real from what's just wishful thinking. But what if I told you that the very method we trust to see the universe clearly has, in a really fundamental way, been preventing us from seeing what's actually there? Okay, so first up, let's do a quick refresher on the version we all remember from science class. At its heart, it's really just a systematic way of asking questions about the world. It's a super rigorous procedure to make sure we don't end up fooling ourselves along the way. And you know the drill. It usually follows these 6 classic steps. You see something interesting, you come up with a hypothesis to explain it, you make a prediction, and then you go test it. And then, based on those results, you analyze what you found and you revise your idea. It's this incredibly powerful loop that just keeps refining what we know. But here is the million-dollar question. Is this powerful loop testing reality itself, or is it just testing our ideas about reality? Because that distinction, well, it changes everything. And this brings us right to the core of the issue, what we can call the perspective problem. It's kind of like the difference between the map and the actual territory, or the blueprint and the final building. This really exposes a huge gap in how we think about things. See, on one hand, we've got our models of reality. These are the theories, the equations, all the stuff we create. But then, on the other hand, there's the machinery of reality, what the universe is actually doing underneath it all. The scientific method is absolutely brilliant at testing the model, but can it ever really truly touch the machinery? This quote just nails it. We could create a completely flawless model that predicts every single thing we measure with perfect accuracy, but as the source material puts it, even a perfect model might only describe appearances. It would just be a perfect description of the shadows on the cave wall, not the actual objects casting them. And why is that? Well, it's because we can never observe reality directly. Every single piece of data we have ever collected comes through some kind of filter. Our own senses, our most advanced scientific instruments, even the very language of math we use to think about a problem, it all stands between us and the true nature of things. We only ever get to see how reality interacts with our tools and with us. Okay, so how in the world could we possibly test for a reality that's fundamentally different from our models? Well, there's a case study from physics called the C-space conjecture that shows just how real and practical this challenge is. The thing is, you can't just use the classic method directly on some new proposed machinery. It doesn't work that way. Instead, you have to build a model of the machinery itself. Then you run simulations to see what kind of physics pops out. You compare that to what we already know. And then, this is the crucial part, you look for totally new predictions that you can try to test for indirectly. And let me tell you, this is incredibly difficult. Why? Because pretty much our entire scientific world, all our experiments, all our equipment is built to test our current models. The evidence for a new kind of machinery could be hiding in plain sight, and it takes just a massive amount of creativity to spot the tiny little anomaly that's actually a clue to a whole different set of rules running the universe. So, what's the takeaway here? Should we just throw out the scientific method? No, absolutely not. What it means is that we need to evolve it. We need to add a new layer of self-awareness to what is already an unbelievably powerful tool. The real, crucial shift is all in the mindset. The classic method, a lot of the time, kind of assumes that the model is reality. But this adapted method makes a clean separation. It acknowledges that for these deeper, fundamental questions, proof isn't going to be direct and absolute. It's going to be indirect and cumulative. A slow, careful building of evidence from a whole bunch of different angles. So yeah, the path forward seems pretty clear. We keep all the good stuff, the rigor, the need for things to be testable, that powerful iterative loop. We just add a crucial and frankly humble layer of awareness. Always remember, the map is not the territory. And this leaves us with a really fascinating thought.
If we actually start by acknowledging our own blind spot, what incredible new things might we finally begin to see? I mean, from the nature of consciousness to the mystery of dark matter, maybe an evolved scientific method is the key that will finally unlock them. What do you think is out there, just waiting for us to find it?